Hey, welcome to the shop. Today I'm going to teach you how to TIG weld aluminum. Now there are a lot of aluminum TIG welding videos out there. I wanted to add one to the conversation where I go over all the basics you need to know, but only in a little bit of depth, just enough to get you started so you don't get overwhelmed in the beginning. So let's start off by talking about what's different in aluminum when compared with other metals, right? Magnets don't stick to it, it's softer, it has a little bit more of a bright appearance, but when it comes to welding, the main things that are gonna have an effect on how you weld are: one, it melts at a lower temperature, and two, it has a stable oxide layer on the surface. And pretty much all metals have an oxide layer on the surface, which just means that the surface atoms of the metal have reacted chemically with the atoms in the air. The reason this creates a challenge with aluminum is this oxide layer is stable to a much higher temperature than the temperature at which the aluminum melts. So to understand what this means, let's look at one of my favorite snacks. It's M&Ms. Now you look at these M&Ms right here and they look like they're just fine, but if you smash into them, they're actually melted on the inside, but you couldn't see it because of the surface shell. And that's how aluminum is. So here I'm going to go ahead and take a TIG torch and start welding on this with a DC or direct current setting that I would use on a nether metal. And if you look, it's really making a mess. It doesn't look like it's melting at all, even though it's melting under that surface oxide layer, just like those M&Ms had the chocolate melted under the candy shell. And you can see it's drooping off here and just looks like a total mess. So in order to combat this oxide layer, we can actually etch it off using a different polarity. So it's like putting your batteries in backwards, right? On something, you just switch the positive and negative. So when the torch switches to where the torch is positive here and the workpiece is negative, that will etch the oxide layer off. And then when you switch back and the torch is negative, that puts heat into the part, right? And so you switch these back and forth, and that lets you etch the oxide layer off to reveal clean, clear, bare aluminum, and then put heat into it to make a nice weld pool. So look here where I start making a weld pool with alternating current, and I get a much nicer, cleaner result there. So we'll take a look at these. You can see what it was like just with direct current that put heat into the part versus when I was etching that away. I got a much cleaner, nicer result with the alternating current. And so that's why it's important to weld aluminum with alternating current. So to do that, you need a machine that will output alternating current, and that typically costs a little bit more than machines that just output direct current, or actually quite a bit more in a lot of cases. So I have two machines that will weld like this. One is called the Miller Dynasty, and I've had this machine for a long time, about 12 years, and it's still going strong. It's a really good machine. They still make a Dynasty today, though it's an updated model from this, but I'm really happy with it and have gotten a lot of good work done with it, and it's a staple here in the shop. Now, I also recently got a different machine. It's a Prime Weld TIG 225X, and this machine is way less expensive. It's about $800 for a machine like this, compared with a Miller Dynasty like this. By the time you buy this and all the accessories, you're looking somewhere around $3,000 or $4,000. And when I started, that was the only option. So it's great that now there's more options to look at. So if you haven't purchased a machine, I'd recommend looking at, it just depends on how much welding you're gonna do and how long you're gonna do it. But I think these entry-level options like this Prime Weld really open the doors for a lot of people to learn this skill. Now let's talk for a second about torches. There's a lot of debate on torches, whether you should use a torch with a gas lens like this, or whether you should use a standard collet body that's a little bit narrower. And there have been really good welds made with both. So I wouldn't spend a whole lot of time on that. I'd just use whatever you have. If you do have a variety of different cup sizes, I would use something in the range of 5, 6, or 7 at the biggest. I wouldn't go too big on the actual size of your cup. but really just use whatever you have there. I wouldn't spend a lot of time on that till you get your technique down. So as far as the tungsten electrode goes, I used for a long time orange seriated electrodes, and I've kind of switched to blue lanthanated electrodes, and either one will work just fine, as well as probably half a dozen others. But for me, it's easier to just keep those blue lanthanated electrodes around and sharpen them up. And I use 3/32 of an inch or 2.4 millimeter electrodes for this. And for my machine, running an inverter like this, I just sharpen the electrode right down to a point. So this is a little sharpener that I made on a previous video for about $25 that lets me get that perfect diamond ground point on my tungsten electrode. And so I just use that to get a nice point, and it'll ball a little bit as I weld, but that's not a big deal. So that's how I do it. If you're running a transformer machine, one of the larger machines that just runs, at 60 hertz, then you may need to put a ball on the end of your tungsten. Some of the most popular ones of those are the Synchrowave or Lincoln Square Wave, the older version of Lincoln Square Wave machines. Now, along with these machines come a whole myriad of settings, and it can be overwhelming, right? Looking at all the knobs on the face of one of these machines, it can be a little bit scary, but there are just a few settings that you need to take into account, and I'm going to show you each one of those. The first one that I'm going to talk about isn't on the machine, it's actually the gas flow rate. And this is pretty important when you're welding aluminum, right? So when you set your gas flow rate, I wish I could give you a number that's going to work for you, but it's going to depend on the cup that you have and your particular situation. In fact, even when you change different types of joint configurations, you can tune this in a little bit, but I run right around 10 to 15 cubic feet per hour with my setup. So that hopefully helps get you in the ballpark, but you might need to adjust a little bit. So in order to know how to do that, let me show you an example. Here I turned the gas too low, like way too low. And if you watch, I can't even get a weld pool. This is just a total disaster of a mess. Now I turned it up a little bit to where it's just slightly low, and you can see I'm able to get a weld pool and kind of get something going, but it's still just dirty and messy. Now, on the other hand, you can have it too high, and the telltale signs that your gas flow rate is too high is, one, you'll have a very loud arc, right? It'll just be buzzing right in your ear, drive you crazy. The other one is, if you notice here, I have the gas flow rate turned way up, the etching zone, right? So we talked about how the aluminum gets etched off when it's on the positive side of the cycle. That etching zone will be really wide. So look at this. So as I run along here with this high gas flow rate, I've just got a really wide band of etched material. And that can come for a couple reasons, but one of the main ones is flowing too much shielding gas. So in summary, you want to have it high enough that you get a nice clean weld, but not so high that it rattles your brain and etches too much of the material. So that's what you're looking for on gas flow rate. Next, let's talk about amperage. And when you're welding steel, a good rule of thumb is, for every 1/1000th of an inch, use about an amp. So on 1/8 of an inch thick, or 3.2 millimeter thick material, you'd set your machine right around 120 amps. I usually turn it a little bit higher because I use a foot pedal. On aluminum, you should put it a bit higher. So we're going to be doing our work on 1/8 of an inch material, and we're going to set the machine here right to 150 amps. Now, this is a good setting for me because I have a foot pedal that'll let me back off and vary the amperage a little bit, but I'll be getting, right into it using most of that 150 amps at different points during our welding today. So that's one of the easier settings to get a feel for whether you're running too high or too low. Next, let's talk about the settings that have to do with alternating current. Now, there are really two here that you could be aware of. One is frequency, and if you have the option to adjust your frequency, which most inverter or smaller style machines will have, I'd recommend just putting it 100 and running 100 hertz until you get your skill down, and then you can tweak and adjust from there. But just so you understand what this does, I'll run one down at 60 hertz, which is what older transformer machines would run at. And we can take a look at that. You can see I mean, first of all, you can hear the difference. It's running at this lower frequency, like you hear transformers buzz from the 60 hertz there. But I get a nice wide bead, and this can help penetrate a little bit deeper on some material. Contrast this with, I've turned it up to 200 hertz here, and as I weld with this, you can see that the bead is just narrower and more focused there a little bit. But again, I wouldn't spend a lot of time on this till you get your skill down there. So just kind of interesting to know that that's a knob that you can turn to get a little bit different result. If we look at them here, you can see that we have a wider bead there with that 60 hertz compared with the narrow bead at 200 hertz. Next, let's talk about AC balance. So we talked about AC, or alternating current, where you switch between the torch being negative, and that puts heat down into the part, and the torch being positive that etches the oxide off. Well, the interesting thing about this is you can change how much of the time is positive and how much is negative on most inverter machines. And some transformer machines have a similar thing you can do, but we'll focus on the inverters because those are going to be more common for beginners today. So when you have your torch and it's on the negative side putting heat into it, that's really using your energy most efficiently to be able to create your weld pool. And so you'd like to spend more time doing that than you do etching. You need to spend enough etching to clean, but most of your time putting heat into the material. And the way that you change how much time is used for each of those parts of the cycle is called AC balance. And so I like to run right around 70 to 75% electrode negative, which means 75% of the time, or 70% of the time, I'm putting heat into the material rather than etching the oxide off. And that works pretty well for me on most good clean aluminum. You might have to tune it for your situation. But there is one little trap with this, and that is that different machines will have an opposite setting, right? So my Miller Dynasty here, I set the number at 70 or 75 on AC balance, and that 70 or 75% of the time is negative. On my prime weld, on the other hand, I'm actually setting how much of the time is positive. So I need to turn it clear down to 25 or 30% to get the same result that I get at 70 or 75% on my Dynasty. So you'll just need to look in your owner's manual for your machine, or look around online to figure out which way it is. You'll be able to figure it out pretty fast, because if your balance is set way too high on a machine like the prime welder, way too electrode positive, your electrode will just ball up and like ball back. And you'll probably still get an okay weld, but you'll be getting a lot of heat back into that tungsten electrode there. And while it's okay to form a ball on your electrode if that's your preference, it's better not to do it too severely while you're welding, right? To have it roll back on you, because you'll have things a little bit out of control. So anyway, if that's happening, that may be your issue. Let me demonstrate here just for a minute on this plate here. So I've turned the balance on this Miller up to 85%, which is 85% of the time is going to be electrode negative, and 15% of the time is going to be electrode positive. And that's not going to give me enough time to effectively etch off that oxide layer. So watch this. You can see it's just making a mess here, right? It's doing okay, but I don't have a nice result at the end because I didn't have enough of that etching side of the cycle to clean the material. And so on the other hand, here I've turned the balance way down to 50%, and while this camera view doesn't let you see the tungsten balling up, it is, and you can see there's more light emitted as the arc length is getting long, and it's really out of control, and I'm not able to maintain the technique that I need, and so I didn't get a good result there either. So those are some of the signs to look for when it comes to AC balance, to know that you have it set right. Now that we've gone over the settings on the machine, I think you should be able to have things set well enough to get going, right? I'd start out with your, at least for this 1/8 inch material, I'd set the machine right around 140 to 150 amps. I'd set the frequency to 100 hertz and set the balance to 70 or 75 in that neighborhood, and that should be good enough to get you going there. And with the gas flow rate, start off somewhere, I'd probably start off right around 15 CFH, but it's going to depend on your torch setup there, so you'll have to tune it in from that. Hopefully that gets you going. Now let's talk about welding technique, and this is really the most important part. And if you master the 4 different elements of TIG welding technique, then you're going to be doing really well. So the first 3 are the same for stick welding, TIG welding, MIG welding. It has to do with your arc length, right? How far you are off of there, your angle of your torch, and how you move. And then I'll add a 4th where we'll talk about adding filler metal. So first, let's talk about your arc length, and this is the first thing to get down, right? So when you go, you don't want to touch your electrode down to the material, but you don't want it to be too far away either, right? You're looking to be right in there, right about, on aluminum, you can be about a 1/16 of an inch, or let's see, what is that? About 1 to 2 millimeters away from your material on aluminum, and you'll be able to start to get a sense. You want to be in as tight as you can be without dunking your electrode all the time. So don't be way back there to avoid dunking your electrode, because you're not going to get the result that you want. So if you just look right here, as I'm running here with a long arc length, I'm really having a hard time maintaining the pool that I need, and if you look at the result, it's really not very good. So let's talk about the first thing to do when you start to get your arc length right. So the first thing when you start an aluminum TIG weld is to form your weld pool. Before you add any filler, before you're moving around anything, is you're just forming that molten puddle. And I'd practice this a few times before you move on. So get down there to where you're feeling comfortable holding your torch at the right arc length, and go ahead and push your foot pedal down and initiate an arc, and watch it, and you'll see how this shiny metal pool appears and emerges. And that's what you need to have happen before you start welding along. And it feels like a long time, at least to me. It feels like it takes a while to do that. So here I'm doing that 3 times, and you can see I'm just trying to get the same diameter weld pool every time and really get that dialed in. So that's really the first thing to get a handle on, right? So once you're able to form a weld pool, let's talk about your torch angle, because this is pretty important. Right, so as you weld along, it's important to take and tip your TIG torch a little bit, right? You can run almost straight up and down, but tipped just slightly there in the direction that you're going to travel. You don't want it to be tipped backwards. It should be pointing forward, and that's going to work out better for you, because as you start to add filler metal to it, you want to come in here, you know, about perpendicular or even a little bit higher from the torch, and this is going to let you do that, to add that in. So once you're able to hold that angle, go ahead and just practice running that along there with the arc on or with it off. Just maintaining that angle all the way along your part, right? Just maintaining that same distance and angle. And once you have those 2 things down, you're a good part of the way to having a good technique that's going to give you a result you'll be happy with. Next, let's talk about your movement. And when it comes to movement here with TIG welding, you really just need to have a nice steady moving hand. Now you can step along a little bit in between adding filler, right? So you're pushing it forward, and then you'll slow a little bit. So you might not be moving just straight consistent across, but whatever you're doing on a large scale, it needs to be consistent. So that brings us into feeding filler metal. Now, when we take a look at adding the filler metal, one of the things that you might see when you get started, and I know I had this problem come up quite a bit, till I got a sense of how to control my torch better and how to feed the filler metal into the right spot, is the filler metal will actually melt off and blob in. So I'll demonstrate that here. So watch this filler metal coming off of here, and it's melting and then just dropping in the pool. That's not going to give you a result that you'll be happy with, right? Because the filler metal is getting contaminated and oxidized before it goes in, and it's taking all that junk into your weld pool, and we don't want that. And so if you're struggling with that, there are 3 things to correct it. 1, make sure that your arc length isn't too long, because that will make it more difficult because you have that large weld plume, right, that cone coming off. 2, make sure you don't have way too much torch angle, because that won't help either for the same reason. And 3, make sure you get your filler metal in and out of the pool, right, in and out of the leading edge of the weld pool quickly. So let's take a look at what that looks like when it's running correctly, right? So I'm adding it in here, it's running really good, and that's what you want to see. So you want to see a result something like this. When you get all these things going together, you'll have a really nice result you'll be happy with. Now let's just talk a little bit about filler metal in general. So there are a few different types of filler metal, but the most common ones are 4043 and 5356. Now, which one you're going to need to use will depend on a lot of things, like your application, what the loads are, the temperature it'll be run at, if it's getting a coating. So that can get really complicated, and there's charts if you search for aluminum filler metal chart that will tell you. But I'm going to tell you, when you're learning, just get whatever you can. And I'd start with 3/32 of an inch or 2.4 millimeter filler rod would be the first one I'd get, and the second would be 1/16 of an inch or 1.6 millimeter filler wire. So those are the sizes I'd get. I wouldn't worry too much about which alloy you get when you're getting started. It's not going to make a whole lot of difference to you. But if you are welding something that's a critical application, you need to understand what alloy you're welding on and what alloy filler metal is the most appropriate. So when it comes to filler metal with aluminum, you have to add quite a bit more than you do with other materials. And in order to do that, it helps to be able to feed it with your hand, right? Like this. This is the way that I do it, and it's the way I've seen most commonly. So if you pinch in between underneath your thumb there and in between 2 fingers on your hand, some will do it between their index and middle finger, and some will do it between their 3rd and 4th finger. Either way works fine. I think the 3rd and 4th finger gives me a better angle to go into the pool, but I just work on it like this, and you work back and forth between bending your fingers in and pulling it out, or using your thumb and thinking about it more with your thumb pushing it in. And this takes a lot of practice, and don't feel like you need to be able to do this before you can TIG weld aluminum. But what I would do is I'd figure out the style that you want to learn to feed the filler metal, right? If you want to do it like this, I would hold the filler metal in my hand this way and then just dab it in. That way you're used to holding it like this, and then as you get more used to welding, then you can work in actually feeding the filler metal in. And this took me a long time to learn how to do, so I won't worry about it. But I wouldn't hold it like a pencil, because then you're just going to have to relearn these other habits. And there are other ways you can find online to feed the filler metal that work better for other people. Just find what works for you, but this works for me. So let's just talk for one last minute here about welding a joint. So all of these things become even more critical when you're welding on a joint. I'm maintaining my arc length, my angle, I'm moving consistently, and adding filler metal. And so those are those 4 elements to work on, and work on them one at a time. Just focus on one thing, and that'll be the fastest path, I think, to getting the skill down that you want. I'm still working on my aluminum TIG welding. I'm always trying to get better, but it feels good when you get something out that you can be happy to put in one of your products and something that you make. Hey, well, thanks for tuning in today. Check out my TIG welding basics video down in the description below, as well as other videos on the channel if you want to learn more. We'll see you next time.